In this video, we're going to be talking about parts of similar triangles. And we're going to say that if two triangles are similar, then the following corresponding parts are also proportional to the corresponding sides. So let's take a look at the first one. Altitudes. You can think of altitudes as sort of like the height of the figure, right? So this is our altitude right here, and this is our altitude over here. So if the triangles are similar, then over here we'll say that BD is to FH the same as AB is to EF, right? If the triangles are similar, then following corresponding parts are proportional to corresponding sides. So this idea of AB and EF, we could have used any parts. We could have said BC and FG, right? So just as long as they are corresponding sides, okay? Next, you'll sort of notice that most of this is pretty intuitive. We'll move on to angle bisectors. Now again, what does it mean to bisect an angle? It's this ray or segment, right? And right here we notice that this angle and this angle are cut precisely the same, and this angle and this angle are cut precisely the same by this angle bisector. Okay. So what are we going to say? Mind-blowing information. QS, this angle bisector, is to UW, this angle bisector, right, this part, is in proportion to QP to its corresponding side UT over here. Again, it's could have been QR and UV. It doesn't really matter as long as it's a corresponding side length. Okay, mind-blowing. And the third piece in our conversation will be a median. Now the median here looks like it's just like that angle bisector, but notice there are no congruency marks on the angles. Instead, the congruency is over here. So what a median does is it comes from a vertex, in this particular case H, and it meets the opposite side right at the midpoint. So J is the midpoint of segment GI. Thus, GJ and JI are the same length. Notice KN and MN are the same length. That's because this must be the other median. So, of course, we're going to have a proportion statement with our two medians. And it sounds a little something like this. Segment HJ is to segment LN is in proportion to segment HG, or GH is to KL. And as always, we could have used this other side here too if we wanted to. So here's our three pieces. Now let's put this into action. Okay, this first problem, as I look at our triangles, I notice right here and here I have some congruency notation. It looks to me that segment SW and segment DF are our medians. So we know that if we have triangles that are similar, and these triangles are indeed similar, then the proportional statement SW, the median from the left triangle, is to DF, the median from the right triangle, is in proportion to, say, oh, I don't know, ST is to DE. And how do I know that ST rolls with DE? Well, ST are the two first letters here, and DE are the first two letters here. So now all I'm going to do is just substitute in the known or given information. SW is X, so instead of SW, I'll write X. Instead of DF, I'm going to write 15 is equal to, instead of ST, I'm going to write 16. And instead of DE, I'm going to write 20. So now I have a true and solvable statement. So I'm just going to go ahead and cross multiply and solve. I'm going to get 20x is equal to 15 times 16. And a quick little bout on the calculator gives me 240. Divide by 20, divide by 20. Okay, x is going to be 12. And there you have it. Nice, nice. Just a little quick sidebar. Had you set up the same median statement with the other two sides, it still works out to be the same answer. So just in case you're like, well, hey, what if I had used these two? Would that have mattered? Nope. As long as you're consistent and correct with your initial proportion, you should be good to go. Now, as we move on to this other side here, I notice that I have my 90-degree angle on this segment that goes from one vertex to the other side. This is an altitude version. But it's really not that important that you actually even know that's an altitude. You just say, hey, I know that these triangles are similar, so the pieces of them should be also similar. So 8 is to 10, that's the two altitudes. And I started with the 8, so I'm going to jump to 14. Now 14 references KL. If I look up here, KL are the last two letters. I look over here, HI are the last two letters, and HI is X. So I have 8X is to 10 times 14, which is just 140. Divide by 8, and we have X is equal to 17.5. Again, that's 17.5. My 5 was a little shady. All I had to do here was solve for X, so I think I'm done here, and I'm done here. Let's move on. I'm going to jump to number 4, and we'll take a look at what we have here. Notice that this length on the outside, right? This is our altitude, right? Another altitude problem. And how do I identify that it's an altitude problem? Because of the segment measured from one base to the opposite side at 90 degrees. Now, when the triangle happens to be obtuse, and these are both obtuse, the altitude will always fall outside of the triangle. Not to worry. We're just going to say 12 is to 15. And again, I'm going from left triangle to right triangle is equal to, since I started with the 12, I'm going to grab the X at this point. And the only thing I need to be careful of now is that I'm really pulling the right side. Now, there's only one number over there. It's 42. Obviously, that's it. But P to Q, first two letters here, U to T, just verifying that 42 is indeed the value that I want. Okay, and now all we're left here to do is cross multiply and solve. So you finish this one. On number 3, come over to number 3. And what do I see? I see some, looks like we've had angles bisected. So this is the angle bisector version. Okay, no big deal. I have my 32 on the triangle on the left is in proportion to the 24 on the right. Same as, okay, and I know this because my triangles are similar. Now, who's going to be on this right side here? Well, I started with the 32, so I got to start with the 38. 38 is AC. AC are the first and third. EF, come over here. EF is X. We're looking good. Cross multiply and solve. You finish that one as well. By the way, they're both going to work out to be decimals. Sorry about that one. Okay, number 5, what do we notice? Looks like we're dealing with medians because we have this segment that cut the opposite side in half. And again, not to worry, we're just going to go from 20 over to 12, right? Compare the two medians. The ratio of 20 to 12 is in proportion with, if I'm going to start with 20, I started with the triangle on the left, right? So I'm working left to right, so I got to do that over here. So my left is going to be 2x minus 9. And that rolls with YC. YC are the last two letters. LH is over here. So LH is X minus 2. Okay, now when I cross multiply, don't forget to distribute into those parentheses. So you're going to get 20 times X minus 2 is equal to 12 times 2X minus 9. Okay, and you go ahead and finish up that one. And just so you know, that should work out to be a fairly nice answer. Well, those are pretty straightforward, and so is this. It's just a little wordy. On the triangle angle bisector theorem, an angle bisector in a triangle separates the opposite sides. So here is my angle bisector, and what does it do? It separates the opposite sides. Who am I talking about? AD and DC, okay? It's going to separate those opposite sides into two segments, right? We got the two segments, the blue and the green, that are proportional to the lengths of the other two sides. Who are we talking about? Blue goes with blue, green goes with green. So how do we write this as a proportion? We're going to say that our AD is to DC, right? AD is to DC, as AB over here is to BC over here. Right? And I just forgot to color that one in green for you. So what happens if we wrote it a different way? Could we have just said the two blue sides, AD is to AB, as DC is to BC, right? And notice I used the two angle bisector cut pieces, right? These right here. And what happens when I cross multiply using this version? I get AD times BC. What would I have had originally? AD times BC and DC times AB, right? I got that. So however you want to do it is up to you, as long as you're consistent, right? Left, right, up, down. Just stay consistent in your comparison. All right, now let's see if we can put this into action. All right, so we have number 6. Let's first take a look at these two pieces. It says if KM represents an angle bisector. So KM does bisect that angle. And so what do we have? We have 4.8 is to X. Now 4.8 was the side on the left and X was the side on the right. So we're going to say left, right, left, right. So now I want to pick a side from the left. 12 is to side from the right, 18. Left, right, left, right. Now what? Now let's cross multiply and solve. So we're going to get 12x is equal to 18 times 4.8 would give us 86.4. Divide by 12, divide by 12. X is going to be equal to, and no one said these answers are going to work out nice. You know, it's not odd for answers to have some decimals in them. No big deal. Cross multiply and solve. I'll just kind of press pause and catch up because I'm going to spin the picture around a little bit. All I'm saying is just think about your paper like my screen here. You know, if I don't like the way it looks, I can always spin the paper around so that it's easier for me to see it, you know. But I think I can see this one just fine. So I'm just going to make this nice and large to work on it. And again, this KM, right? They said that KM was my angle bisector. Okay, so that's bisected, which means that these are my two pieces that were a result of that angle bisector. So I'm just going to go from bottom to top triangle. So I'm just going to say 36 to 40. Now since I started with the 36 first, I'm going to start with the X first on the right side. And when I went from 36 to 40, I'm going to go to X to 54. Now you finish, cross multiply and solve. No big deal. It does come out to be a little bit of a decimal answer. That's okay. Now we're still dealing with the same situation. It's just that I really need to know what this is worth. If the small part is 15 and the entire part is 39, then I guess 39 minus 15 will give us 24. And it's going to be this piece. And now we're all set to set up that proportion. We're going to say 15 is to 24 as X is to 36. And why did I choose that order? I just grabbed 15 arbitrarily. So if I'm going to say 15 first, and then I'm going to go over to the 24, then 15 goes with the X, 24 goes with the 36. Now again, I said earlier, right, I'm going to cross multiply and solve, or you're going to cross multiply and solve. And 8 comes out to be a decimal answer, no big deal. But what if I had originally said 15 is to X? What if I did it just like that? Because 15 does roll with the X side. And then I said 24 rolls with the 36. When I cross multiply and solve, what do I get? 15 times 36. What are you going to get right here? 15 times 36. So again, it's about consistency. It's not that there's the best way to set it up, although my first version is the most formal way to set it up. Not the only way, though. So you finished number 8. I'm going to jump over to number 9 if you want to press pause and finish up 8 and come back. So either welcome back or we're just going to go back and work on it later. If this is 12 and the whole thing is X, then what is the blue piece going to be worth? Well, before we said this was 39 and 15, so 24 is the result of 39 minus 15. So ML is going to be worth x minus 12. Right? This is that length. So now we have 12, that's the left side, is to the right side. X minus 12 is in proportion to, the left side again is going to be 18, and the right side is going to be 30. Now, while we're here, might be noteworthy that 6 goes into both of these. 6 goes into 18 3 times, and 6 goes into 30 5 times. Cross multiply and solve. And what do we get? 3 times x minus 12 is equal to 5 times 12. That's going to be 3x minus 36 is equal to 60. Add the 36 to both sides. And I'm going to be getting the 3x equal to 96. Divide by 3, x is equal to 32. And had you not done the little reduction technique up here and you use the 18 and 30, it's okay. You still would have arrived at x equals 32. All right, let's move on to our last example. Okay, we made the last one nice and big. Again, we need this length right here, and that's going to be 45 minus 27. Gives us an 18. So that's 18. And so now, I don't know if you want to call this like the top triangle and the bottom triangle. Working from top to bottom, we're going to say 27 is to 18, as top again is going to be 3x minus 9 is to x plus 11. Now just again, don't forget there's implied parentheses here. And as always, I'd like to think about the fact that this is easily reducible. 9 goes into both of these, 3 times and 2 times. You really want to start thinking about knowing your factors. It's going to be key in Algebra 2. All right, we want to start talking about that. So 2 times 3x minus 9 is going to be equal to, 3 times x plus 11. It's going to give us 6x minus 18 equals 3x plus 33. So on and so forth. You finish. This one, okay? And that's a shady finish, I know. Looks like Frisk. It works out nicely. At least I left you with a nice problem. So at this point, you should have numbers 1 through 10 complete, right? In their entirety complete. Check that in with me, and then I'll give you the next mission, should you choose to accept it, which you will. It's not really a democracy. All right, onward and upward.